Hi Brian, just a quick little video for you because I know that you'd probably be a little bit daunted trying to set up RhinoCAM on your own there up in Canada. I've just literally reinstalled this on this machine. It didn't have it on yet. My wife runs all my pathing stuff, so I don't even know if I've got tools set up in here. Do I have tools set up in here? No, I can't even remember where to find the tools. RhinoCAM cutting tools browser. Alright, so I've got the same tools in here that my wife would have sent you earlier today. So you obviously, I see from the forum, you figured out how to load them. Now, that's one thing giving you all the tools, but without telling you what it is they do or how they work, it's not teaching a man to fish, it's giving him a fish. So let's have a look at creating a new tool. Now you have to bear with me because I haven't done this in ages. So let's go there, create a new tool. So when you pull this up, now I got that, let's start again. So that was your first, in your tool browser, that was the first little guy over there, create or edit tools. And when you pull this up, and notice that on the top, you've got a whole heap of tool types, alright, including one of the question mark, which is a user-defined tool, in case you buy something that's not up there. For the large part, you're going to be working with flat end mills, round end mills, and tapered cutters with flat ends, or tapered cutters with round ends. The tapered cutters with flat ends and the tapered cutters with round ends, I define them as one type of tool. I don't even bother to define the fact that it's round. And if there's anybody else who's not a jeweler watching this video, stop watching now, because this is recorded for somebody who's going to be cutting wax. There's a lot of tolerance and a lot of leeway in wax that there isn't in metal, and this is not a setup video for people that are cutting metal. Alright, so let's have a look at the first tool. The first tool, if you hover your mouse over it, will tell you that's for a ball mill. Basically, a ball mill is a straight tool that comes down dead straight. Its end terminates half round like this, and it can have flutes. Now what we mean by a flute is the cutting edge that faces down, and the cutting edge up the side. There's like a spiral that travels over. How many cutting edges are there? So that's the number of flutes that we're talking about. And you can determine these over here. Most of the jewelry ones that you're going to buy in these type of things are going to have 3 flutes. If you're working with plastics, you'll cut stuff with 1 flute. Different metals, you'll have different numbers of flutes. Most of the time I don't even bother to set this up. You must remember that this software was designed for people who have far more demanding needs than us as jewelers. We cut wax, doesn't really matter how many flutes you use. This kind of tool will typically only be used as a roughing tool anyway. So the one tool that I set up like this is I have a 1mm ball end, I have an 0.8 ball end, and I have a 3.17mm ball end, which I think are probably, there's my 3.17, and the rest are not in there. Alright, so let's define one quickly. Alright, so let's have an 0.8mm ball end. The holder diameter is sort of like how big is your chuck. I don't ever bother with this up the top here. I don't care. The first thing to start with is, let's call it, I'm going to call this 0.8mm long reach ball end. Alright, the difference between long reach and standard is long reach has just got a lot more cutting shank available, which is handy for us, as because we cut wax, we can go in a lot deeper than most other people. We also need to reach deeper areas. You'll see when you start buying tools what the difference is between them. I'm not going to confuse you too much now. Holder diameter, I've never bothered to fill in. Holder length is how deep down is your chuck set. I've never bothered with that either, because we jewelers and we cut really small pieces that are never more than maybe 30 or 40mm radius from the center of your rotary face. So this info here really is for guys cutting engine blocks, where the whole head of the mill is going inside of a block of metal and it's cutting areas, and RhinoCAM needs to be able to stop collisions with the actual drill, the spindle, and the spindle mount, etc., colliding with anything. Where I do add an amount in is the tool length area. Alright, so let's 0.8 long reach typically has got about maybe 6mm of cut, then it tapers out, and it has maybe 15 to 20mm of shank on it. So all up you're probably looking at about, I don't know, let's call it 25mm. Alright, what this will do is, this length here, RhinoCAM will keep when you're going to cut something, how far in can I push this tool before I'm going to start colliding with the holder. Alright, you don't want to push this in any deeper than that, so you leave that to 25 mil. Alright, the flute length is how long is the cutting edge. If you think of it like a drill, grab a drill out of your toolbox and look at the drill. There's a spiral cutting edge that goes up and it stops, and then there's some clean shank. Now the flute length is that cutting edge. How long is that cutting edge? Now, like I said before, on an 0.8 long reach ball end, you've got about 6 millimeters that it goes in. Only the first 2 millimeters is actual cutting length, and then the rest is a long thin shank that comes out. It's not really important in our case. In the scenario we're talking about now, it's not too important. So I'm gonna put in there 6 millimeters. Where this will matter is when you use this for doing roughing. Alright, so you need to be a little bit careful about how you define things over here with long fluted tools. So if you wanted to be technically accurate, you would have said about 2.5 millimeters is your actual flute length, where the cutting section of the cutter is, and the total tool length is maybe 25. The problem with that is these tools are really thin, and your shank is 3.17 millimeter holder up at the top. So you go from a fat shank on a tool down to a really thin shank on a tool down to a really short cutting area. So it kind of depends when you look at the tool how you want to define how far it will push this in. If you define your flute length as 2.5 millimeters, you're probably going to need to stop your tool length at, say, 6 millimeters, so that it knows not to plunge the tool down. If this was a 3.17 millimeter cutter, where the shank and the cutting of the tool is all one size, it would have made no difference. You could have left this and that both as long as each other. The diameter on this particular cutter is going to be 0.8 because it's an 0.8 millimeter ball end. Okay, so I'm going to try sketch out what I've done over here. Let me move this over, and I'm going to. I can't work two windows at the same time. Let me see if I can fire up another instance of Rhino. Hello, Rhino. Hello, another Rhino. Another Rhino. Give me another Rhino. Give me another Rhino. Oh, no. No, it doesn't matter. We're just going to draw on it. Okay, so I'm going to grab this and just move it out there so we've got some space in the video. And then I'm going to work in the front view, and I'm going to draw what I've done over here. I'm going to take a line and I'm going to draw. Let's put on snap. Snap, 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 snap. And I'm going to say from there, let's have a look at what we did. Let me set my snap settings. Sorry, it's new machine I've set up, and I'm not entirely sure how everything was set. Snap settings, make it at 0.25 millimeters. Okay, snap back on, and let's draw a line from this 1 millimeter interval. So I've said my cutting length, flute length, is 2.5 millimeters. So 1 millimeter, 2 millimeter, 2.5. All right. I terminate that line there, and said my total tool length was 6 millimeters. Okay, so I'm going to go from here. That's 1, 2, 3, 4, 5, 6. Alright, now what I was explaining to you before is that because this is a long reach cutter, let's draw another line, it actually looks something like this. It has I'm going to draw a line, both sides from there, 1.585. Why am I going 1.585? Because 2 times 1.585 is going to give you 3.17 millimeters. So the shank on this guy is this wide. It comes straight down. Let's take a line. It comes straight down until it hits round about this area here. Okay, I'm going to draw a line both sides from here. 0.4 millimeter, because 0.4 is half of 0.8. Alright, so the cutter width is this wide, then it comes, the cutting area comes up from here, so let's draw a line until it gets to this point, and then over here it runs out of teeth, so to speak. Then from here, it doesn't want to let me, well, okay, so from here there's a half round point, which is this, Then it goes up for 2.5 millimeters where there's actual cutting thread. I'm going to draw that to represent the lines for you. Hang on a tick. This is a little bit heathen. Let me turn that damn snap off, it's irritating me. So this is your representation of your cutting teeth on this thing. Let's say something like that. And the cutting teeth actually stop round about here. Then there's clean shank. I don't want to confuse you too much, so what I'm going to do is I'm actually going to draw a little arc over there. Okay, and that arc actually sits at this point. Okay. Now, so what's happening is, this is that tip over there. Let's draw a line to remind us where our cutting edge ends. So that's the end of our 2.5 millimeters. Okay, then there's a straight shank area that comes up here, and then there's a radius section that comes out. Where are we? Then there's a radius section that comes out something like this. All right. And your tool looks round about something like that. So I'm going to grab this guy. I'm going to split it with that. Okay, chuck away that bit. Sorry, didn't see there wasn't anything on the bottom there. Split you with a point. Thank you, and delete you. So let's grab you, and you, and you, and you, and you, and revolve. And there, and there. Alright, so what you got, let's just to ghosted mode, and so what you've got is a cutter that looks something like this. Okay, the shank of the cutter comes down plain with nothing on it. It keeps going plain for about that long. Alright, then the last 2.5 millimeters actually got cutting edge on it, and then it has a ball end. So to get back to where we were, what we've said over here is that our total length from the tip to where we hit this area here is about 6 millimeters. If you make this longer for a tool that's tip is narrower than its shank, what's going to happen is RhinoCAM will find a cavity that's say 0.9 millimeter or millimeter wide, that's maybe 7 millimeters deep, and it will look at this and go, oh, you've said 20 millimeters, so I can safely plunge this tool down 20 millimeters into a cavity that's only 1 millimeters wide. Of course, what will happen is this section of the tool will destroy that. So when you're defining tools, always be aware of whether the actual tool section is narrower than the shank of the tool, how long the cutting length of the tool is, and in here, that's what these little guys are denoting, right? So the diameter is, well, it's the diameter. You can't really go wrong over there. You just look at the tool when you buy it. If it's an 0.8 long reach ball end, it's 0.8. Do sometimes just throw a vernier over it and double check that measurement, because there's tool suppliers and there's tool suppliers. Right? Some of them will say 0.8 will be 0.7, others will be 0.89. Can make a difference when you've got high tolerance parts. Okay, so the flute length area that we were discussing is this over here. So let's highlight those. That's the cutting section that will actually cut. This section here will just slide along the wax. If you set all of this as cutting area, it may bring this up against a block of wax and try cut the side, remembering that these cutters are designed to not only cut at the tip, they're also designed to cut along the flute length area of the tool. So if you told RhinoCAM to go in next to a block of wax and face a section of wax, and you told it that this cutting flute length was all the way up, it would run this section against the wax, and all that would happen is the wax would superheat and melt against the tool, and your part would be destroyed. So don't over define a tool if you don't necessarily have to. Okay, so the flute length will also be on the tool packaging, or you can just take a vernier and measure where the cutting edge of the tool ends and pop that in over there. Alright, so this, you've now given it a name. We know what all the rest of this is. These top two over here, I've never bothered to fill in. These sections over here are a little bit critical depending on what you're doing. So I've for this video, I've particularly grabbed one where the shank is smaller than the actual, where the cutting tool is smaller than the shank of the tool, because these are a little bit more problematic to set up than regular tools. Alright, so this you would go save as new tool, and you would save your library out. So let's move on to the next one. We have a flat end mill, which really is exactly the same as a round end mill, except that it's flat. Okay, same rules apply. You've got the same tool lengths to qualify. You've got the same diameters to qualify, same flute lengths. Let's have a look at some that I've drawn. So in my 317 end mill, which is pretty much a standard end mill, I think everybody on the forum would use them, I've defined a flute length of 15 millimeters, a tool length of 25, which means this can go in 25 millimeters, 15 millimeter step downs when it's doing extreme roughing. Alright, my diameter is 3.17 millimeters, which is what the tool is. That's a 1/8 for the Yankee Doodles. You could go in and fill in flutes. Technically, my tools have 3 flutes. Couldn't be bothered. I'm cutting wax. Okay, when you're cutting hard metals, this can be critical in determining whether a tool burns out or not. For wax, doesn't really matter. Alright, let's have a look what we've got over here. A corner radius mill. Now, what the hell is the difference between a corner radius mill and a half round? I suspect that this one is completely half round. A corner radius mill I've never used, obviously, is a flat tool with a corner that's radiused off. What do we got going in over here? A V-mill. This is an engraving cutter. I don't think at this point in the game you need to worry too much about these. Chamfer mill. Oh, this is an interesting looking fella. I don't know that I've worked with this one before, have I? Now, the one that I use the majority of the time is this. This is a, what's that pop up? What do they call it? A taper mill. Now, most of the cutters that you're going to buy from Bits and Bits have a 3.17 millimeter shank that comes straight down, and then the tool tapers at an angle to a point in the front, or what looks like a point. And this will be probably what you will be using the most when you're working with RhinoCAM. You'll be working with probably 15 degree 0.127 millimeter cutters. So let's have a look at defining one of these. In my particular library, you can tell what I use. I don't bother with finer cutters because really I don't have the need for them. The finest cutter I use is a 3 thou cutter, an 0.076 millimeter 10 degree spiral. I have some 6 degrees somewhere. The 0.127s. The 6 degrees I only use when I'm doing really fine walls. Now, before I define one of these, what I might do is just open that other Rhino window and explain to you about a cutting tool and walls and why there's different degrees in there. So let's get back in here and let's delete all of this. Okay, and let's get in the flat view. So I'm going to draw a line from F4 straight up, like so. Alright, I'm going to draw a line, angled, start of the baseline, end of the baseline. The pivot angle I'm going to make it 5 degrees, and what this is doing is it's drawing a line angled to that line at 5 degrees. So I'm going to have to come out quite a bit. What are we? 1.585, about there somewhere. Alright, and I'm going to draw another line from there, both sides 1.585, which is my cutter shank thickness. Let's put the two over each other. There, about there. Alright, and let's draw a line from where they intersect, straight up. Okay, so that was probably the worst designing I've ever done. Anyway, not important. Let's grab these two and join them and revolve them from F4. Okay, so what I've just drawn is a 10 degree cutter. Okay, now when you buy these tools, you're going to see them often referred to as 10 degree or 5 degree or 6 degree. When you buy them on eBay, it will confuse you because sometimes in eBay they don't define it the same way we do. bits and bits happily use the way that I'm showing you now. 10 degree is the total angle, alright? The angle from this area to this area. Have I got some lines over there? Whoa, deep edge. Let's grab that edge and that edge. Alright, and let's grab you and you. Explode you. Alright, grab more top here and dump it. Have we got any duplicates in there? Yeah. Alright, I'm going to hide that so we can have a look at what it is we're doing. Okay, so you remember when I drew this, I drew a 5 degree angle outwards and then I've revolved it around. So that means the total included angle here is 10 degrees. I'm going to do a dimension, a angle, dimensions, select the first line and select this second line and put it in there. So what we have is a total 10 degree included angle from this end to this end. Okay. The reason this is important is when you define this, it actually gets defined as a half angle, not a full angle. So I'm going to show that cutter again. Alright. So this is a 10 degree cutter. Its tip at the moment is infinite because it's in Rhino. Alright. I'm going to draw a line 0.127. Oops, start of the line, end of the line. 127. Alright, so a 5 thou cutter would have a tip, say yay thick. Alright, so when you zoom back, you can tell that all of these things look like they've got no tip, but at the end of the day, if you had a 10 times loop or microscope and you zoom that up, this is what a 5 thou cutter looks like. So let's draw another line from here, shift tab outwards, 0.076, which is a 3 thou cutter. Okay, so the 3 thou cutter's tip is a lot finer. It can get into smaller crevices. So a 3 thou tip, as you can tell, your flute area is longer. Where they gone? Wow, can't see where they are. There we go. Right. Okay. It can get into smaller places, but it also means that because it's thinner, it can break easier. Alright, you can get them all the way down to, I think, 2,000. I'm not 100% sure if those are available yet or not. But typically this cutter over here, which is the 0.005 5,000ths, is what I use for 99.9% of the cutting that I do. When I do really, really fine stuff with high detail areas, I might jump in with this typically for crest rings or signets or that kind of thing. So I'm going to dump those two lines now. Actually, I might not. I might just take this and split it, and we'll keep this for later. Split it with that. Alright, and this is our defined 5 thou cutter. Alright, so that's what that cutter looks like. It may have a slightly longer shank or not as long. Alright, so with the foreknowledge of what we got going on there, let's go back to defining this tool. I'm going to move it, say there, and pick this in front of it. Alright, so that's not going to work for me. No, sorry. Alright, we'll have to play back and forth a little bit. So again, what it's asking is, the first thing let's get out of the way is, what is the flat diameter? Please hold 1 second, I've got to make a call. Okay, phone call. Alright, so let's get the tip out of the way because that's the easiest one. We know what size that is. It's 0.127. I define it as 0.126. Buggered if I remember why. Alright. This particular tool we've got highlighted as a 15 degree. I'm going to highlight a 10 degree. Alright, so the flute length. Okay, so take a caliper and measure from here to here how long that cutting depth of the tool is. I don't know if it's dimensionally accurate or not, but mine is defined as being 10 millimeters long and the total tool length as being 20. So the total tool length in this case is from the tip here to how far this tool can go into the wax before it starts colliding with my holder. Alright, so I've got that defined as 20 in this case. The taper angle is where this gets confusing for some people. You will see I've got mine defined as 5. Have a look at, I can't zoom this up for you unfortunately, have a look at where it's asking you to define it. It's showing you a line here and it's showing you the tool angle there. So it's wanting to know what is the taper angle here. That's not the total included angle, that's just the angle, which is half of total included angle. So that would be 5 degrees. In the case of a 10-degree tool, you'd fill in 5 degrees here. So 5 degrees plus 5 degrees will give you your 10 degrees that we were talking about earlier. And really, when it comes to defining tools, that's about it. Okay, you're going to get the best bit in the whole world is a 10-degree tapered ball end mill. And you may ask yourself, how do I set that up? There's no ball end mills here. You can define that by setting a corner radii here. Okay. Should you do it? No, it's a complete waste of time. Okay, because all that adding this corner radii will do is it will make your tool path be really slow when you're generating it. It will also have depth issues because tapered tools with radius, there's something funky that happens around here. At the end of the day, the only difference between a regular pyramid flat and a pyramid with a ball end, when you're talking about a size like this, 0.126, is the fact that one's going to give you a better finish than the other. Other than that, I do not bother to change the definition. The one place you may want to change a definition, and this is an older library I think, is what we've started doing is on the taper angle, we've made it a little bit fatter. So we'll take that to 5.5. So your total included angle is 1 degree bigger to allow for the fact that sometimes the tool may not be defined or cut 100% correctly by the manufacturer, but more importantly and more useful is that when you're cutting a flip plus a flip and a rotary, if your tool is defined as being a little bit wider, when you're cutting the flip, RhinoCAM will cut it thinking that it needs to leave a bit more leeway on the wax. The tip of the cutter will still be cutting everything it needs to cut, but the wall of the cutter will be doing a little bit of protection, 1 degree of protection when it's cutting the flip. So when you come to do the rotary, you haven't got tool marks over the curved surfaces of your ring. This is not going to make sense to you now, and I've just realized that probably I shouldn't even be trying to explain this to you now. Just for now, put in the actual defined taper angle of that tool. Okay. I don't think there's too much more to explain about these tools. It looks like very complicated space rocketry going on in here. It's not. Okay. Basically, you've got the tool in front of you. When you bought it, you know what the angle is. It's 10-degree tool, so your taper angle is 5. Your flute lengths, expensive tool manufacturers will give you all this info on the packaging, but otherwise just grab a vernier and measure. All right, caliper, I mean. And just fill in the info as you need. Don't bother with corner radii in the case of these tools. And that's about it. I hope this video was useful to you, matey. Have a good one. Chris out.